love space. It's so cool. Hello everybody, welcome to my stream. Today, I just want to relax and fiddle around with the world. In canon, I have the powers of just altering everything in existence. Maybe not everything, but matter. A lot of matter. So in canon, I can technically do pretty much everything that I can in this game. And this is Universe Sandbox. Now, from the game itself, you can probably tell what I'm supposed to do in this game, and that's just to fiddle around. Just look, experiment, look at the beautifulness of space. Beautifulness? Is that a word? I don't know. But goddamn. Just from looking this simulation of how our solar system looks so pretty. Now, I'm not here to tackle the entirety of the solar system. I'm too dumb for that. So let's just get Earth. Let's just get Earth. Good old Earth. There. Earth and Moon. Hello Luna, welcome to the stream. Is that our galaxy? Well, one of us are this. I can look at the Milky Way, which is our galaxy. So this is Earth. Whole humble Earth. This is where we live. This is the entirety of our existence. Without this world, we are nothing. So let's blow it up. Now, first nightmare scenario that people think to end the world if somehow the moon would just crash into Earth. And one thing I can do to actually do that is to just make Earth very heavy. So let's change the density to let's do a 500 density. Oh man, that is not doing anything, huh? 500 is nothing. Haha, let's change that again. How about a good old 1,000 density? Oh my god, well everything is gone. It's been overtaken by water. Well, everybody's dead. Checkpoint, I guess. The moon is doing a slight curve. The slightest curve. Okay, let's bring it back to 5. There. Man, it looks like a marble. Okay, it is obvious that I've messed it up somehow. Let's just do this again. Earth and the moon. Please, am I dumb? Can I not see? Earth and moon. There we go. There. This is Earth and the moon. Single Earth, single moony. Okay, what I can do is... Okay. How did Earth 8 feet backwards and this Earth will start to freeze? Yes. But I'm not here to freeze the Earth for now. I'm here to make the moon crash into Earth. Can I make it to just density? Actually, no, I don't want to save it. Okay. I can just make the density very, very high density. What if I just kilograms? Grams? Yeah, let's do kilograms. Okay. Let's do 6,000 kilograms. Is the moon doing anything in any way? Nope. Wow. While the Earth is freezing, fuck. Are you interested in astrology? Yes. I love astrology. I love space. I like cosmology. I like anything to do with the stars above, the heavenly bodies. Okay, that's too close. Let's lock you and do 9,000. Earth is doing fucky. Let's just move the moon closer. That is not how you make it closer. That is to make it also then 600. That is It's not doing much. That's probably good 100 hours per second. Ah, there it is. Okay, it's doing a slight curve. Very slight curve. Doing good. Very slight curve. What I can do is let's do Earth's density a little bit higher. 10,000. Oh. The moon, oh, okay, the moon is still here. Why is it repelling backwards? It's being ejected from the orbit. Huh. Okay. Well, Earth is moving at a very fast rate. Let's also just make it bigger. Oh, okay, well, Earth went supernova. That's not very good. Well, Earth's been destroyed. Check mark. It's been destroyed. Is this this is what remains of Earth? It's okay. Well, check mark. Let's do that again, but this time, how about we just we crash another Earth into Earth. Let's crash another Earth into Earth. There. Okay. Okay, that orbit is gonna be fucked out the window. There's 2 moons. Oh, these 2 moons are gonna collide. Oh my god, they're gonna collide in the next rotation. Oh, Okay, Earth is entering a binary system. Will it survive though? How? Okay, let's do 10 hours. 10 hours a second. Okay. Oh god. Oh no, moon's gonna crash. Oh my god. Okay, so one Earth is freezing to death and the other Earth is a burning fireball. How are you freezing? Oh my god, it's freezing. Oh no, that's not freezing. 311. That's barely above boiling point. How? Is it? It's in an ice age. Is it the density? Where's the other moon? Oh, the other moon is very far back. Okay, Earth. God, that's so cool. Okay. This Earth, let's make it a bit heavier. No. Massier. 100 mass. Oh my god. Well, that was a bit too much. Did it turn into a black hole? No. It's just... It went... What is this? It's 0.309 the mass of Jupiter. Where's the other moon? Oh, the other moon is curving. Oh, that means it's very dense. How much is the density on this? It's not too bad. Oh, damn. Okay. That's a lot of fragments, though. That is definitely a lot of fragments. What if I add another Earth to it? Adds another Earth? Will it enter a binary system again? Okay. This is smaller, so it could act as a moon. Unless it hits a fragment. It's orbiting. Good. Orbiting well. Doesn't seem like it's gonna crash anytime soon. Yeah, I don't think it's gonna crash anytime soon, but that curve is very irregular. Eventually it's gonna crash into it, because just how heavy the fireball Earth is. Oh man, it's dropping in temperature. So it's cooling down somehow. It's cooling down. That's interesting. It's cooling down. How about this other Earth? Other Earth is... Oh my god, other Earth is completely dead. Other Earth is completely dead. Oh man, that is death. There's nothing there. Oh. Then again, it's freezing. That is below 0. Get it? It's so cool. There's so much fragments orbiting this Earth. Okay. What if I target the other Earth? Other Earth, thank you. Other Earth. It's no. Oh god, no. It's targeting. Okay, just pause. It's targeting a fragment for some reason. Okay. There we go. There we go. Now I want to make this bigger, a bit bigger, just twice the mass, so it could just swallow up all those fragments. Oh, well, the other Earth's orbit is destroyed. It's gonna crash very soon. Oh man, that is highly irregular. Wow. That is cool. Hello, Brandy. Welcome to the chat. Welcome. I'm just messing around with the universe. Good thing we're not gonna die right now. Distance to you. Okay. So it's still technically dropping in temperature. That's fine. That's technically fine. Okay. Let's do another increase in mass. Oh, well, everything is getting shot. Oh my god. The gravity of this fireball Earth is ripping the other two in half. Look at all those fragments leaving. Oh my god, look at all those fragments over there. Well, that is a giant fragment. Yeah, look, these fragments over here are dying. What are you? Can I close in? Oh no, they're that far away that I can't even close in. Do you see its irregular rotation? Oh no, it's 10 hours per second. That's why it's going hyper speed. What I can do is I can slow you down to an hour a second. Okay, it's oh I thought it was gonna crash. Wow, this Earth is still no, it's actually averaged out on temperature. Huh. It is ripping apart the other fragments, but eventually, after it's taken enough fragments away, it will actually just crash into it. Yeah, see, some fragments are not coming back. Like, these fragments are not coming back. If this moon has been ejected from the orbit, and these two are the only things following it right now. Regular rotation for magnetic field. I don't think the magnetic field has changed aside from getting a bit more massier. It is 1.24 the size of Jupiter, so it's big. It's bigger than Jupiter. It's 0.24 times bigger than Jupiter. My question is, how is these two still crashing? If Jupiter, if something the size of Jupiter and the mass of Jupiter is here, it's very massive. It's very massive. Oh, you know what I can do? Is I can add helium, or if I just add hydrogen, eventually it'll turn into a star. Huh. That did diddly. That's doing nothing. It's not changing the mass by any chance unless... Oh my god. Oh, because it's literally nothing. Okay. Let's do 2.5. 2.5 the mass of Earth per particle. Is that doing anything? Oh, it became a gas giant. Okay, it became a gas giant and temperature dropped down. Oh, okay. So the moon crashed in. Half of it. Oh, oh, that's so cool. Just fragments ripping apart from everywhere. Eventually, these Earth will eventually crash in. It will crash in soon. Let's add more hydrogen and see if it ignites. More hydrogen. Oh, it's gigantic. Okay, I'm gonna turn back away. Oh. Okay, Earth crashed into it. That is, oh, it's dropping in temperature. I don't know why. Is it because there's not a lot of things to burn? Oh. It's 5 times the size of Jupiter, but it's not, it has to be bigger than that, of course. It has to be at least like 120 times the mass of Jupiter for it to actually go solar. Hydrogen. It is growing big, 7 meters, or 7 times the size of Jupiter. Okay, how about let's do 10 times the mass. Boo, where is it? 10 times the mass. Huh? Am I not allowed to use the size of Mercury? Alright then. 10 times moon. Huh, it's changing. 800 auto mass, no. Let's do 200 times the mass of moon. It's cooling down. It's cooling down. It's like huh. I don't know why. It's cooling down. This is 10 moons per particle. That's 10 moons per particle. Dude, that did nothing. Okay. Pulse? Pulse do? Ring? What? What does it do? It did nothing. Okay. Ah, I love the colors. It's so pretty. I know, right? Let's do hydrogen, moons, 200 moons. God damn. Okay. That's 200 moons. It's cooling down significantly. What? Is it? Ah. The gravity is technically putting it apart. It's still dropping. It's nowhere near enough size. Okay. That's the Jupiter size. Okay. 5 Jupiters per particle. Is that enough? Should be a lot. Oh. Okay, it's heating up. Oh, there we go. There we go. It went solar. It went solar. A very cold star, but it is still technically a star. Okay. It's technically a star. That is not a lot, though. That's very cold. That's only 0.300 Kelvin. That's Kelvin, right? That's Kelvin. Okay. It's not a lot. Okay. Let's do 10 Jupiters per particle. That 10 Jupiters per particle. Well, the epic music is doing a lot for me. It's very cold. Oh, but the gravitational field is insane. Is it gonna reach? What is this? Can I make star out of nothing? Can I just make like a tiny moon and turn it into a star? Okay. Oh. Oh, it's doing a gamma ray burst. Why? Is it collapsing on itself? It's doing a gamma ray burst. Look. Why? It's not massive enough to turn. It's not massive enough to turn into a black hole. But that gravitational field, though, is insane. It's 2 kelvins. 2 units of Kelvin. Luminosity is 5 times the sun? 5 times the sun? What? 5 times the sun. So this is technically all probably because of the energy. That's the thing giving it light. It looks beautiful. If I add a bit more, oh, everything is getting pulled, but it's getting scattered. Now it looks like a spirit bomb. It's growing, it's growing. Neutrons and electrons. Oh, there's a giant ball of particles over there. Well, I'm certain I have to move up an inch here. Let's do... Let's throw the sun at it. Let's throw the whole damn sun at it. Yes. Oh, it's smaller than the sun. That's probably why. So it's a very tiny star. It's an incredibly tiny star. It could be a gray dwarf. A gray dwarf, you say? Okay. I need to turn this into a blue... Oh! I thought something happened. Material. Hydrogen. Yes, hydrogen. Let's do... 2 suns per particle. That should be it. Okay. It's not... It's massive enough to turn into a black hole. 100 times the sun. Should be a lot. Oh god, it turned into a black hole. It turned into a black hole. There it is. It turned into a black hole. Is everything? Oh my god, everything that's so far away is still getting pulled back. Can I make it massive enough to hold a galaxy? I wonder. It's not big by any means compared to other black holes. Like if I add our Milky Way, if I add our Milky Way, it's literally just a speck. If I add the Milky Way, it's a literal speck. Here's our Milky Way. That's nothing. Is there a supercluster I can add? A banana! A long sword. Aries? Okay. Apparently not. It's gigantic. Okay, how about if I add another black hole? If I add another black hole. Oh, what? That's a lot of minutes. Do 1 minute a second. 1 minute a second. Oh, even at 1 minute a second, that is... Wow. Okay. These 3 black holes... This black hole right here is orbiting... Wow. It's doing good, doing good. Oh, hello NRJ. Welcome to this chat. Stream chatting. It's orbiting goodly. Okay, can a star theoretically, very theoretically here, star, our sun perhaps, can it orbit? Maybe not that close. It'll get ripped apart by the others. Oh my god, it's orbiting good. Oh no, the orbit is very unstable. The orbit is unstable. That's gonna die. If I crank it up faster. Yep, it got eaten. Well, I made Earth into a black hole. So check done. That's killed. No more people. Also, I just wanted to look at this. This is Andromeda Galaxy. This is the closest galaxy. That is the closest galaxy to us. And it will collide with our galaxy, the Milky Way. Now, you may think this is incredibly fast, but you are seeing billions of years a second. You are seeing billions of years a second. So even if we look at it now, if we look at it with just our normal 1 year a second, it looks almost static. But hey, trust me, that is moving millions of light years per second. Megalight year. 10 megalight years a second. Even then, that is a crazy amount that is this crazy amount of time. That is 1 billion years a second. And yet still, it's not that fast. Of course, it's fast right here because it's a simulation and we can comprehend how it looks. But eventually, these galaxies, these stars, will merge, and our skies will be filled with red light, trickles of multiple birth stars. And probably we're long gone by now. We're probably dead by now. But even if we think about it, that if Earth still exists, this would be a marvel to see. Once in a blue moon, once in a lifetime, once in billions of lifetime. What I'd give to just see this. But if we look at it where we are, even do 100 years a second. That's, let's say, the furthest a man could live. 100 years a second. Static. Literally nothing. Trust me, it's moving. It's moving fast. It may not look like it, but it's moving. Wow. So beautiful. It's 100 years a second. It's nothing. It's 100 years a second. Every second a man dies, static. It's nothing. Literal nothing. That's what I love about space, because it's so mind-bogglingly huge that you just can't comprehend it, even though you try. Like our solar system, just us. This is just us. This is the entirety of what we know, what we can see with our naked eye. Let's do a day a second. A second. This, most of us, is all we see. Just Earth. Home. Anyway, tangent over. Let's try another thing. I want to terraform Mars. I want to terraform Mars. Because think about it. This is Mars right now. Cold, dead, red planet. But what if it could be more? There's every possibility that life could exist in Mars. Not as much as on Earth. And also, water exists on Mars. On the south, on the north, in the poles, there are waters. And if you think about it, to get this started, you're looking at multiple generations, hundreds of years, just for a chance at terraforming Mars. For a chance. And even if we have the chance, even if we get there, we're still looking at an impossible geoengineering. It's beautiful. So let's terraform it. No, don't want to destroy it. How about just the Mars and moons? There, the Mars and moons. This is it. This is moons. This is Marsy Mars. This is Marsy Moon and her moons. It is technically tilted, but so is our Earth. It's a bit more tilted than what Earth is. So amazing how vast the heavens are. It's also terrifying, just how move stuff, the feet, throw everything off. I know. So beautiful. Anyways, let's terraform it. So one thing we can do is add a little bit of carbon dioxide. Now the reason being why we add the carbon dioxide is because Mars currently doesn't have a magnetic sphere. It doesn't even have an atmosphere. So it's nothing. So if we add carbon dioxide, that is a lot of moons for carbon dioxide. It's just to 10 moons a particle. We add that. It's growing. Oh my god, I'm adding so much. Okay, this is probably way too much. That is way too much ice. Okay. Alright. That is way too much. Okay, let's use way too much. Let's just do normal amounts of hydrogen. Or not hydrogen, of carbon dioxide. Normal amounts of it. Probably Earth's atmosphere mass. One Earth's atmosphere amount of carbon dioxide. Well, that's very slow. Oh, the gravity is way too much. How big is the Mars? The Mars, you know, how big is it? How massive? It's fine. It's still below zero, very much below zero, but not too much from Earth. Carbon dioxide. Just a moon's full of carbon dioxide. A moon pool. One day. One day a second. One day a second. There it is. That's a lot of ice. Till technically goods. Okay, so that's almost covering the entirety of Mars itself. Is it actually covering? Oh, that is a lot of ice. That is definitely a lot of ice. But hey, that's still good. Okay. Next, we can add a little bit or a lot of water. See if that actually helps. So water. A lot of water. Is that enough? It's not stripping away. The water is not stripping. It's not getting pulled out. So, okay, a little bit to the side too. Teensy amounts of water. Trickles. All the moon is the Mars is gigantic now. It's more akin to a super Earth. Next, from water, we can add oxygen. Just probably some kilograms of oxygen. A kilogram of everything is nothing. One moon worth of oxygen. Moon oxygen. What's going on? Oh, it's killing everything. Why? Why is it killing the water? Is it because there's not enough carbon dioxide? It's very cold still. It's almost as big as Jupiter. Do the mass of Earth. 15 times the mass of Earth. And of course we need hydrogen. But yet, oh well, it's gone. Everything is gone. Now it's a gas giant. Huh. Not what I was going for, but sure. Okay then. Alright. Not what I was going for, but sure. Can I just do a flat nothing? Flat nothing. Nothingness. Ah, yes, there we go. Nothingness. Whole lot of nothing. Okay, let's add Saturn. Where's your ring, Saturn? Oh no. I have to build the rings itself. Maybe there's an already simulation for Saturn. There it is. Saturn with rings. There's her rings. If you look far away, it's literally just like the wings or the rings we know Saturn for. So cool. Okay. Saturn around the sun. That, well, Saturn's the only thing here. Other than Mars, if you could, which planet would you like to see colonized? Ah, a planet to see colonized. Maybe an exoplanet. I just don't know which one exactly. But I would probably want an exoplanet in Proxima Centauri. Somewhere around there. I know there's a poster, or there's a planet in Proxima. Is it here? No. There's a planet in Proxima Centauri. It's orbiting a red dwarf. So everything there, every plant would be red. I want to see that colonized. That would be unbelievable. I believe there's a poster for that too, though. It says everything is red on the other side in Proxima Centauri, something along those lines. But yes. Okay, how about I make a supernova on Scratch? Okay, let's add the sun. The sun is nowhere near. Maybe not. Spica. Can I make Alberion? Can I make Alberion? Okay. Where is it? Okay. Rangus. No. The Spica is here. Ah, I don't think. I think I have to do a separate simulation for Alberion. It's not even here. Am I dumb? Do I just not know the spelling of it? Alberio double stars. There it is. I am dumb. Okay, it's not here. Okay, so I have to make it. I have to make it myself. Sure. Okay, so the stars I need. Stop. The stars I need is beta. Beta. No. Get off my face. No. I'm looking at the wrong things. Huh. Hmm. No, no. Ah. It's thickness. Okay. Somewhere around here. Is not it. I guess I just make it my own, huh? Get two similarly sized stars. So one, ooh, that is big. Athena? Oh, that's not Athena. Okay, there. Bit small. Okay. So it's a blue and a orange star. That's too big. That is way too big. That is entirely bigger. Hmm. This is the biggest. This is the dwarf. Where is it? Man, I'm dummy sick, huh? Dummy sick? No. Hmm. There it is. Okay. They're similarly sized, technically a little bit. Not really. Huh. No. Oh my god. Every small Vega. No, not Vega. I guess I can make the summer triangle. But that's not what I want to do. I want to make Alberia. I guess I can't, because there's no such thing. Oh, well, fuck me then. Suppose. How about I just make... Oh. How about a summer triangle? Where is it? Altair. Altair. How about let's pause? Okay. Altair. No. I want to add. Oh my god, let me add something. Vega. And Deneb. Oh, Deneb is the biggest. Okay, let's see how this plays out. Oh, I think. Oh, ho, ho. Altair and Vega are doing a straight beeline to Deneb. Yep, they're doing a straight beeline to it. Oh no, Altair and Vega are orbiting each other. Man, the Neb is bigger than I thought. Then again, that's probably why it's like the brightest of the summer triangle. Is it gonna crash? I want to know. Let's do days per second. A day per second. Ah, it's gonna crash eventually. But let these two orbit each other for a bit. Oh, the Neb. It's gonna crash Vega first. Oh no, Vega's gonna be pulled. Ah no! Vega and the Neb is destroyed. Altair remains. Why? Why is Altair the remainder? Man, that's skyrocketing. The temperature is skyrocketing. Can I crash another Vega to it? Ooh, no. Vega. Because technically 2 Vegas should just, that's Altair. Okay, so these two could it's already a binary system. Oh shit! I already made a binary system. Granted, this could exist in real life and we just haven't seen it, or I haven't seen it. It's not crashing, from what I can see. If I turn up the days, let's do 7 days a week. Okay. It's not crashing. Okay, it's doing a beautiful ballet. Gonna be stuck there for millions of years. In months. A month a second. Oh, that's fast as hell. Okay, it definitely doesn't seem like it's gonna crash. A year a second. No, it's not crashing. Vega is growing though. Okay, final test. Let's do giga years. A single giga year. No. Okay, it's definitely not gonna crash. That's certain. Definitely gonna crash. It's not gonna crash. Oh, that's not a lot of time. Let's do a day. It's not gonna crash. Wow. It's beautiful. That is so cool. Okay, enough goofing around. Let's destroy Earth another time. Open simulation. Earth. Earthy. Tidally lock Earth? Tidally locked Earth? Oh, Earth is tidally locked. They were quite literal with that. Just a single day. Why is the atmosphere so much faster? About an hour. Oh, the atmosphere is ginormously large. Sedna. What's Sedna? A dwarf planet? Chiron? Chiron is very far away. Okay. Pluto. Pluto. Ah, I'm getting sidetracked again. What if I crash every planet on Earth? Ah! Earth. Nope. Okay, let's just make a new empty simulation. Let's add Earth in. Earthy. Okay, Earth. Let's stop time. Mars. Venus. Mercury. Jupiter. put Jupiter somewhat close. Saturn, Uranus, and then Neptune. Those are the main planets. Sorry, Pluto. Fuck you. And bah, everything's gonna crash. Oh my god. As expected. Why is Uranus alive and not Neptune? I suppose Uranus is a tide bigger. Oh, it's ejected. Okay, it's ejected. Oh, goodbye. These two are gonna collide. Okay, so Uranus has been ejected by, I suppose, and Jupiter swallowed. Oh, there it is. It's dropping in temperature, so it's not large enough to become a star. What if I add okay. What if I add a black hole to it? Sagittarius A. Oh. I suppose I was a bit too how about it in a banana? Just an hour a second for a banana. Banana? Okay, the banana is... Why is there a banana? Why is there a banana? Why do you exist? Well, anyways, I suppose that's enough time. That's enough time for now. I'll be uploading a new video later in a couple hours. Not a couple hours, and it's probably gonna be another day before I can actually upload it. But for now, that should be the end of the stream. I've been streaming for an hour. Just good relaxing stream. But thank you guys so much for watching, and I will see you in the next video. Good night. And then me end the stream, and then there we go.